Today we're going to talk about deductive reasoning. We have already talked about inductive reasoning, conditional statements, and conjectures. The first definition that we're going to talk about is deductive reasoning specifically. Deductive reasoning uses facts, rules, definitions, or properties to read logical conclusions from a given statement. So again, we are observing facts and given information to reach a conclusion. Deductive reasoning is also about coming to a conclusion based on general rules. It starts with broad statements and draws specific conclusions. So let's do a quick comparison between inductive reasoning and deductive reasoning. Inductive reasoning is based on patterns of observation, and it starts with a specific observation and moves towards a general conclusion. For example, I can say that it rained on Wednesday. That's a specific observation. My general conclusion is it will rain every Wednesday. That's inductive reasoning. Deductive reasoning is also based on patterns and relationships and observations, but it starts with a general observation and moves towards specific conclusions. So, for example, all dogs bark at cars. My dog will bark at cars. All dogs barking at cars is general, but my dog Lucky will bark at cars is specific to Lucky. One type of deductive reasoning is called the law of detachment. I am not concerned that you remember what the law of detachment is specifically. I just want you to be able to use deductive reasoning. So it states, and if we remember back to conditional statements, if P, then Q is a true statement. So if my hypothesis followed by my conclusion is a true statement, if P is true, then I know Q is true. So if the first part's true, then the second part is true. So here's an example. And a lot of times deductive reasoning is easier to understand with an example. Given, if a car is out of gas, then it will not start. So a car is out of gas is my hypothesis. My conclusion, or Q, is it will not start. This is a general piece of information. If a car is out of gas, then it will not start. The specific part is going to be Sarah's car is out of gas. So that's my hypothesis. So the conclusion I can draw then is Sarah's car will not start. So again, my hypothesis is true. My conclusion is true. This is a general statement. Sarah's car is out of gas is a specific statement. Therefore, I can say that Sarah's car will not start is a valid conclusion or Q. Here's another example. If a student turns in a permission slip, then the student can go on the field trip. The specific part is now Philippe turned in his permission slip. So the conclusion that I can draw then, I go from general to specific. If any student who turns in the permission slip can go on the field trip, and Philippe turned in his permission slip, then my conclusion is Philippe can go on the field trip. And then we have to ask, is this conclusion valid? And because my hypotheses match and my conclusions match, this is a valid conclusion. Here's my example. Here's a statement that we know that says if 3 points are non-collinear, then they determine a plane. That's a definition we learned in chapter 1. My next piece of information is points A, B, and C lie in plane G. Because we know that points A, B, and C are in the same plane, and we know that 3 non-collinear points make up a plane, the conclusion we can draw is that points A, B, and C are non-collinear. But then we have to ask, is the conclusion valid? And at that point, we have to examine our hypotheses and our conclusions. So 3 points are non-collinear is a hypothesis. They determine a plane is my conclusion. If I look here at my hypothesis, the hypothesis in the first statement and the second do not match. The conclusions in the first statement and the second statement do not match. So therefore, this is not a valid conclusion. So the law of syllogism allows you to draw conclusions from two conditional statements when the conclusion of one statement is the hypothesis of the other. It also can be shown as if P then Q and Q then R are true statements, then P then R is a true statement. So again, like most of the things we do, this is easier to see with a real example. So here is an example. Given, if you get a job, then you will earn money. And if you earn money, then you will buy a car. Because the conclusion in the first statement becomes the hypothesis of the second statement, they kind of cross out. And we can just then go to, if you get a job, then you will buy a car. Our valid conclusion then is the hypothesis of the first statement and the conclusion of the second. And that is how we go from P to R. Here's another example. Determine which statement follows logically from the given statements. So, if you do not get enough sleep, then you will be tired. If you are tired, then you will not do well on the test. So if we look at this and we examine our hypothesis and our conclusion of each statement, we can see that the conclusion of the first statement, then you will be tired, is the hypothesis of the first statement, if you are tired. So those cancel out, and we are left with, if you do not get enough sleep, then you will not do well on the test. And then if it becomes a multiple choice answer, we can see that it's not going to be A, because you are tired, should be canceled out. B matches what we just said. If you do not get enough sleep, then you will not do well on the test. C, if you do not do well on the test, then you do not get enough sleep. This is reversed. It's the converse, so it is not a logical conclusion. And there is no valid conclusion is not an option because we know that B is our correct answer. So if we look at another example that says, if Dahlia finishes her chores, then she will receive her allowance. And if Dahlia receives her allowance, then she will buy a CD. We can see that the conclusion of the first statement, she will receive her allowance, is the hypothesis of the second statement, and they will cancel out. And what we are left with is the hypothesis of the first statement and the conclusion of the second. So our valid conclusion is, if Dahlia finishes her chores, then she will buy a CD. Given vertical angles are congruent, angle 1 is congruent to angle 2. And if we look at this, there's no if-then statement. There's not really a lot of information. There is no valid conclusion that can be drawn since angle 1 and angle 2 do not have to be vertical in order to be congruent. They don't even need to be touching. This doesn't have enough information and there would be no valid conclusion. So here are some examples where you have to decide if we're going to be using inductive or deductive reasoning and if the conclusion is true or false. So all guitars have strings. A harp has strings. That's the given information. My conclusion is, therefore, a harp is a guitar. This will be deductive because I go from general statements to specific statements. However, my conclusion is false because a harp is not a guitar. Here's another example. You see a dog bark at 3 different cars. You conclude that the dog barks at every car. Is this going to be inductive or deductive? So what you want to look at is I'm going from a specific statement about me observing a specific dog, and then I am making a general conclusion about dogs. So that makes it inductive because I saw one pattern, one specific pattern, and then I am making it apply to every case. So this is inductive, and we're not going to say whether it's true or false. It would be false because not every dog barks at cars, but there are a lot that do. Here is another example. Acute angles are less than 90 degrees. An angle is 47 degrees, so it is an acute angle. This is going to be deductive reasoning because I am going from specific information that an acute angle is less than 90 degrees and a specific angle is 47 degrees. Therefore, I can say that that specific angle is acute. And this is absolutely a true statement. Please let me know if you have any questions about the topics in this video. Please feel free to check out the original version on YouTube or rewatch the Ed Puzzle video to gain a better understanding of this topic.